Good afternoon, everyone. We are Group 1 participants, Andrei Ang, Decar Capadiso, and yours truly, Angekyla Barroquillo. Today, we'll be reporting the first experiment entitled Determining the Concentration of Hydrochloric Acid, or HCl, using a standardized sodium hydroxide, or NaOH solution.
Calculations are the foundation of analytical chemistry. Certain experiments are done in the laboratory to gather various data needed for certain purposes. In this particular experiment, our group titrated a solution of potassium hydrogen phthalate, better known as KHP, to estimate the concentration of a solution of NaOH. The indicator we used in this experiment is phenolphthalein. In the presence of excess hydroxide ions, phenolphthalein turns pink. In the second part of the experiment, we also titrated HCl with the known quantity of the NaOH solution determined in the first phase of the experiment to ascertain its exact concentration. Again, phenolphthalein is used as an indicator in the part of experiment. In this part of the experiment, all of these experiments are conducted for us to have a better understanding about how titration works and how to correctly collect and analyze data from experiments.
For the methodology, two parts were performed, where the first part is about the standardization of NaOH, and the second part is about the determination of the accurate concentration of HCl. For the first phase of the experiment, the following materials were used: 1 molar of NaOH solution, KHP, 50 ml burette, phenolphthalein, weighing scale, weighing both, 250 ml Erlenmeyer flask, and distilled water. To start, we performed 3 trials as well as weighed and transferred 2.3, 2.5, and 2.7 grams of KHP respectively to a 250 ml Erlenmeyer flask. Next, 25 ml of distilled water was poured into the flask in order to dissolve the KHP. Afterward, 0.2 ml phenolphthalein was subjected to the flask, serving as an indicator when there are excess hydroxide ions. Subsequently, the burette was filled with 52 ml of NaOH, and then a realistic titration was performed with increments of 0.05 ml. When the flasks turned pink, we stopped the titration, inputted the collected data, and calculated the desired. Moving on to the second phase of the experiment, the following materials were used: 0.1 molar of HCl solution, NaOH with the known concentration from the first phase of the experiment, 250 ml Erlenmeyer flask, 25 ml volumetric pipette, 50 ml burette, and lastly, phenolphthalein. To start, we transferred 25 ml of HCl into a 250 ml Erlenmeyer flask using the 25 ml volumetric pipette. This was also done in 3 trials. Next, 0.2 ml of phenolphthalein was added to the flask. This process is similar to the first phase of the experiment, wherein it will serve as an indicator when there are excess hydroxide ions. Afterward, a precise titration was performed with an increment of 0.05 ml using the 50 ml burette filled with NaOH solution. When the flask turned pink, we stopped the titration, inputted the gathered data, and calculated the molarity of HCl using the concentration of standardized NaOH from the initial phase.
So to determine the concentration of NaOH, a titration involving KHP was done, with phenolphthalein as the indicator. As reported by Straub-Joubbe, the standardization of a volumetric solution, or in this case NaOH, is used for titration is one of the vital preconditions for reliable and transparent titration results. This is because well-grounded titration results can be achieved only through working with the exact concentration of the volumetric solution. Listed in the following table are the essential data obtained from the first titration. So after the first titration, calculations were done to determine the average molarity of NaOH. So given the equation sodium hydroxide plus potassium hydrogen phthalate, it produced potassium sodium phthalate plus water. So the amount of NaOH is equal to that of KHP as per their molar ratio 1:1. So as such, the amount of KHP in moles must first be determined. So we done this by converting grams of the KHP to moles of the KHP in all trials. So next, the volume of NaOH delivered per trial was calculated by subtracting the initial burette reading from the final burette reading. So slight differences in the volume delivered can be observed as different amounts of KHP were used in the titration. So to solve for the molarity of NaOH per trial, the moles of NaOH determined for the moles of KHP was divided by the volume in liters of the NaOH delivered. So the average of the molarities of NaOH per trial was then computed for it to be served as the exact or known concentration of NaOH for part B. So during the course of the second titration, the titrant, in this case NaOH, was added slowly to the solution. So as it was added, the HCl slowly reacted away until it reached the equivalence point. So the average molarity of NaOH calculated from the first titration was then used to determine the concentration of HCl. So slide 10 contains the essential data as to how the concentration of HCl was computed. So once the second titration was complete, calculations were done to determine the concentration of HCl. So given the equation hydrochloric acid plus sodium hydroxide, it produced sodium chloride plus water. So the molar ratio of NaOH and HCl is 1:1. Hence, the amount of NaOH in moles must first be calculated to get the amount of HCl. To calculate the moles of NaOH, the average molarity of NaOH from the previous titration was multiplied by the volume of NaOH solution delivered in liters. So after doing so, the molarity of HCl was calculated by dividing the moles of HCl, which is equal to that of NaOH, by the volume in liters of HCl added. The calculations for each trial are uniform as equal parts of HCl, phenolphthalein, and NaOH were utilized.
Wrapping up, the purpose of the conducted experiment was to learn and establish a foundation of the basics of analytical chemistry. In this activity, particularly acid-base titration. The two-part virtual process involved an immersive demonstration of the necessary steps to be taken in determining the concentration of hydrochloric acid via titration with caustic metallic base sodium hydroxide. The first part of the simulation allowed the standardization of sodium hydroxide by titrating it with a solution of potassium tannate. The latter half, however, completed the process where the hydrochloric acid finally joined the process, being titrated with the then recently calculated concentration of the sodium hydroxide. With the presence of a popular indicator, the tested solution was expected to mid-process color switch in a particular 2-phenolphthalein ratio, or should I say, the endpoint, which should symbolize the point of acid neutralization by the base. This was, however, satisfied in the conduct of this experiment. Moreover, with reference to the tables and calculations mentioned in detail by Jesslyn earlier, we in the group also generally inferred that digits come very crucial in the process. Significant variations occur even in minute content deviations from the intended amounts, say several variations of achromatic, pink, and purple roughly flow in the glassware, directly proportional to the increment of phenolphthaleinic amount being poured per duration. Tactical utilization of the chemistry laboratory instruments, scales, glasswares, pipettes, and burettes, etc., as well as the fundamentals of solid and volumetric measuring techniques while in a virtual setting altogether consisted our primary takeaways upon finishing this exercise. Also, given the strict numerical requirements instructed prior to the conduct of this experiment, and with the post-lab Quizlet handed, we were able to appreciate the value of accuracy, precision, and significant figures as such have critically maneuvered the results of our test trial by trial. In a relative sense, we also bear witness to the effectivity and reliability of the titration process in determining concentrations of analytes, at least in the undergraduate laboratory level, and judging on its procedural structure, which we perform ourselves. I guess that would be all for our presentation. Thank you for listening.